Okay. So hello everybody, my name is James Thomas and I'm a developer advocate for IBM working in our cloud division. And today I'm going to be talking to you about a new way to build and run microservices in the cloud without having to set up or manage any infrastructure to be able to do this, right? No having to provision virtual machines, no having to create containers, install Linux and application middleware, none of that kind of stuff. And you might think this sounds kind of impossible, right? Microservices without servers, right? Surely if I want to run my microservices in the cloud, I have to set up and manage the environments to be able to do this. But today I'm going to be showing you a new approach using serverless cloud platforms that allow you to do just that. And in kind of the middle of this talk, in the second half, I'm going to be doing a live demonstration of using one of these platforms to create some microservices to show you how easy it is to get started. Now, as well as thinking this sounds kind of impossible, right? Microservices without servers. You might also think that it sounds unnecessary, right? You might think, I like my servers. I've got them set up and configured just how I like them. Why would you want to take my servers away from me? Well, the reason is this. Servers kill your productivity, and you might not believe it yet, but trust me, it's true. And I think by the end of this talk, you're going to agree with me that servers kill your productivity. You're going to want to go back to your office on Monday, gather up all of those Linux machines that you have, set them on fire, and be free of the tyranny of looking after infrastructure forever. Right? I think servers are one of the worst things that's ever happened to software developers. So why am I so convinced, right, that servers kill your productivity? Well, let me tell you a story to explain why I feel so strongly about this. Imagine you have a great new idea for a new application or backend or API, and you've got some people who you want to try out. You've got some users ready. So you finish the code, and you want to get it into the hands of your users. So you think, OK, I'll provision myself a server. I'll put my code on the server. I'll give the URL to people, and then they can use it, and everyone will be happy. But what you'll soon realize is, as soon as you provision that first environment, that first VM, that first server, that suddenly you've got all of these extra tasks to take care of, right? You have to install Linux and get that set up. You've got to get middleware on there. And when it's running, you've got to keep it updated with security patches and middleware updates and your code on there. Obviously, you have to think about monitoring when it's running, keeping it healthy in production, make sure it's not crashing. And you need to think about security because you don't want hackers to get in and steal all your valuable customer data. So you have to think about encryption and backups and security passwords, all that kind of stuff. And then hopefully, as your backend, your service gets popular, you need to think about scaling. And for most people, scaling means more servers. And then you can provision more environments, and you can run them in a cluster, and you can worry about replication and failover and state management and all of that kind of stuff. And after a while, you're going to find yourself spending all of your time looking after these servers, after these environments, not on actually writing code in the first place. And as developers, I think it can feel often like we're held hostage by our servers, right? I want to spend all my time in my IDE writing code, and I'm spending increasing amounts of it kind of hunched over some Linux terminal trying to fix some kernel panic. And that's not really what I want to do. I'm not a Linux infrastructure engineer. I want to be focused on my code and let someone else worry about that. Now, at this point, you might think, well, hold on, James, right? Wasn't the cloud supposed to fix all of this? I'm always being told that as long as I put my backends or APIs in the cloud, all of my kind of infrastructure challenges just magically disappear. And in the computing industry, I think we often sell cloud as this utopian vision, right? The cloud computing allows you to treat computing resource, computing infrastructure like a utility model, like electricity or gas or water, where you just provision as much as you want on demand, you use it, and afterwards you just pay for what you've used and kind of throw away the rest. But for many of us who are building backends in the cloud today, and were aggressive early adopters of cloud systems that we think of as like infrastructure as a service, I think the way we use cloud computing today to provision infrastructure is a long way removed from what I think of as a utility model for computing. So let's compare a utility and how you use it. So let's compare electricity. You know how electricity works and how you provision it with how we provision infrastructure in the cloud. So when you get connected to your electricity provider, do you ever get phone calls from them asking you to go down and maintain the power station at the weekend? Right? No, none of us do. I just use electricity. I don't have to think about maintaining the equipment. But with cloud, things like infrastructure as a service, although maybe it's all virtualized, so I don't have to physically buy the machine and plug it in and turn it on, I still have to look after the environments, right? I still have to keep Linux updated, I still have to get my middleware on there and I have to monitor it. And that's not really what I want to do, right? I just want to be running my code without running the environment. So another question is, does your utility provider ever ask you to do capacity planning up front? Do they ever say to you when you get connected, so how much electricity do you need? How much do you need tomorrow or in 6 months or in 3 months' time, so we can make sure that the substation you're connected to is big enough? And again, with the utility model, I don't have to worry about this stuff, right? I just use electricity. I don't think about how much capacity I need in 6 months' time. But again, with many cloud systems today, you have to decide up front how much capacity you need, how much memory and disk space and CPU your virtual server is going to need to power your application for load, for traffic that only happens in the future. And the future is very hard to predict. So often we end up with kind of wasted capacity. And then finally, does your electricity provider, do they ever ask you, do they ever charge you for unused capacity? Do they ever ring you up and say, we're generating lots of electricity at the moment, and you're not using it, but you still have to pay for it? And you think, no, that's not how it works. So I only pay with a utility for the resource that I use. But again, with cloud systems today, you have to decide up front how much capacity you need, and then if you don't have as much traffic as you expected, you've got loads of idle time within your application, guess what? You still have to pay for it. I think this kind of shows to me that the way we use infrastructure in the cloud today is a long way removed from what we think of as a utility model for computing infrastructure. So what can we do, right? We obviously still need some way to run our microservices in the cloud, but I don't really want to do all of this infrastructure stuff. I want to just have a kind of utility compute model in the cloud. Well, fortunately for everyone here today, I'm going to introduce you to what I think is a much better way to build and run microservices in the cloud using what they call serverless cloud platforms. And serverless cloud platforms are built as this next-generation cloud computing service that, for the first time, allows you to treat computing infrastructure, computing resource, as a pure utility model. So let me ask people at this point, who's heard of serverless cloud platforms? Okay, so some of you, that's good. All right, keep your hands up if you've used it or use it kind of day to day. Okay, things like AWS Lambda, OpenWhisk, Azure Functions, that's good. So some of you. But if this term was relatively new to you, right, maybe you heard about it on Hacker News or Twitter, and you were kind of like, what's this serverless thing? And you go to Wikipedia to try and understand how it works. You'll read things like serverless cloud platforms run your code in response to events, right? They manage your computing resources. They allow you to build event-driven applications. And if you read this and you didn't really know what serverless was, you might kind of scratch your head and think, well, this sounds like every other cloud platform out there today. They all say this kind of stuff, that they run your code in response to events and they manage your resources, right? How is this really any different to how I already do it? But serverless cloud platforms are different, and they're different for a couple of reasons. The first is that they shrank the units of deployment. So rather than deploying your application, rather than having to build some big VM image with all the services and database and operating system in there, or even having to create some monolithic deployment package, which you kind of push up, serverless cloud platforms allow you to push the source code, the microservice code, straight into the platform, and the platform executes it on demand whenever a request comes in. And this is where the name serverless comes from. Because with serverless cloud platforms, as a developer, all you focus on is the code. All of the infrastructure stuff is the platform's responsibility. So if you're using one of these platforms and you push some code up, it's been executed on demand to process a request, what happens if another request comes in parallel? Well, with serverless cloud platforms, scaling is the platform's responsibility. For however many requests come in parallel, the platform just spins up a new environment, injects your code again, and executes to process that request in parallel. What we could think of as kind of horizontal scaling. So this means that rather than you, as a developer, having to do the resource planning of how much memory and disk space and CPU does my server need to cope with so many requests per second, now it's the kind of the platform's responsibility, and I don't have to think about resource planning upfront anymore. And as well as serverless platforms scaling up, right, to cope with loads of traffic, they also scale down. And they scale down to 0 because your code is only running when it's actually processing requests, right? It gets started up on demand in milliseconds as API request comes in. So guess what? If you've got some idle time within your application, there's no traffic on the back end, none of your code is actually running. And that's really, really important when we think about the pricing model. So serverless cloud platforms, like all services today in the cloud, it's all pay-as-you-go. You pay for the resources that you use. And with serverless, it's the milliseconds that your functions are running to process requests. But, as I said before, when you're not actually, the only time your code is running is when you're processing requests. So now, all of the idle time, you don't get charged for. And I think this is one of the most disruptive and underappreciated aspects of serverless computing, that for the first time ever, you don't have to pay for idle time within your application. And this kind of effect can lead to some kind of drastic cuts to people's bills in the cloud. I've seen many use cases of people talking about saving 80, 90% of their cloud bill at the end of the month by moving to serverless cloud platforms. Okay, so enough talking in a very abstract and high-level way about serverless cloud platforms. Let me actually show you how to use one and kind of do some live demonstrations of using a serverless cloud platform to create some scalable microservices really, really quickly. So the first thing you're going to need if you want to play around with a serverless cloud platform is you need a kind of provider to play with. And today, there's like a dozen that you can choose from. Serverless as a technology started about almost 3 years ago now, when Amazon came out with a new service to their cloud called AWS Lambda. And that got really, really popular with developers as they realized this new paradigm of building kind of serverless functions in the cloud. But then last year, 2016, I think was the year that serverless really took off with developers. And one of the ways that manifested itself is that all the other big cloud providers launched their own competing solutions. So IBM has one that's open source called OpenWhisk, we're kind of looking at in a moment. Azure came out with one last year called Azure Functions. Google Cloud has one called Google Cloud Functions. So I pretty much guarantee you, whoever you use for your cloud provider, they have one of these serverless offerings for you to be able to play with. And I think as developers, that's really, really important. We have a very healthy ecosystem of different cloud providers and different serverless functions that you can use. Now, the one I'm going to be looking at today is based on an open source project called APACHE OpenWhisk. This was IBM's offering in the serverless space that when we announced it about 2 years ago, we open sourced the whole platform and have donated it to Apache, and it's going through that whole incubation process at the moment. And recently, both Red Hat and Adobe have adopted it as their official serverless platform, so it's getting some nice traction in the kind of open source space. Now, if you're evaluating, which serverless provider do I want to use or which serverless platform, I think there's a number of good reasons to look at OpenWhisk. For example, the first one I think that's important to me is that it's open source. So the whole platform is completely open source. Development continues on it in the open. If you want to see how they work under the covers, you can go to GitHub, to OpenWhisk, and kind of look at Scala code to work out what's going on and kind of play around with it. But I think for most developers, why IBM decided to open source our platform is they think all developers building on the cloud today have this existential fear that they're building on some third-party service or third-party platform. And what happens in the future if they change the pricing model, they deprecate it, they just turn it off? Kind of remember what happened to services like Pass.com, right? Am I going to be stuck forever if my vendor decides to deprecate my service? So we think by building our cloud on open source components, it gives you as a developer as kind of a bit more of a guarantee that even if IBM goes away, you'll still have a way to run your serverless platform on OpenWhisk. So the second thing I like about OpenWhisk is the runtime support. Right? So with serverless platforms, because you are completely abstracted away from the environment your code runs in, you're kind of reliant on the serverless provider to give you the runtimes that you want to be able to use. And if you look across most of the serverless providers and platforms, there's some very common runtimes and some which are a bit more kind of vendor specific. So for example, Node.js is like, I think of as the first class serverless runtime. It's supported on pretty much every platform out there today. OpenWhisk is no exception. We support Node v6. Python's also pretty popular, so if you want to write your microservices in Python, either 2.7 or 3.1 on OpenWhisk, you can do that. And Python's generally well supported on some of the other platforms. Java is also in there, Java 8, so you can use that. But some of the more runtimes that are a bit more OpenWhisk specific include things like PHP. So PHP was actually added recently by a non-IBM or community member into the open source project. So PHP has been the first runtime that's been added through GitHub and kind of open source, which is really, really nice to see. Something that I find really interesting is Swift. So Swift was a language developed by Apple a couple of years ago, primarily for doing native iOS development, and then they've open sourced, and it's become a really popular language for doing all kinds of backend development as well. And IBM has been heavily involved in building out the Swift backend ecosystem, so we've added support natively into OpenWhisk. So you can write serverless Swift functions, push them quite straight up, and execute them on demand without even compiling the code. But by far the best thing I think about runtime support in OpenWhisk is that it's completely extensible. So actually, if you want to use something like Go or Ruby or Haskell, something that's not supported out of the box, any runtime that you can wrap in a lightweight Docker image, you can actually push that runtime straight into the platform and have it executed on demand. So if you want to use a newer version of Node that's not supported, rather than waiting for the runtime, the platform to catch up, you can just wrap your own Docker image and then kind of push that directly up. And that's not something that most of the platforms support. It's kind of an advantage we think of OpenWhisk at the moment. So we're going to play around with serverless cloud platforms, and we've got the platform we're going to use. We're going to use OpenWhisk. And the next thing you need is some code, right? Code that might look a little bit like this. Imagine I've got this myservice.js file. And today I'm going to be focusing on the Node.js runtime because that's my favorite language, and I think everyone can tolerate a little bit of JavaScript. But the question people have at this point is, OK, you've told me that I just write my source code, microservice code, I push it straight into the cloud, and then it gets executed on demand. So how does the platform know what to do with the code? How does it know how to execute it and where to call it when requests come in? Well, for every runtime you want to use, it's kind of the same method where you have to add a tiny little interface to your code that acts as the entry point. So every time an API request comes in, an environment's going to be spun up for Node.js, your code's going to be injected, it's going to be called, and it's going to call this function to process each individual request. And this is what the interface looks like for JavaScript. So you can see you could have a myservice.js file that's 1,000 lines long. It doesn't have to be one function. It can have third-party libraries and modules, and it just needs to have a little interface, which is a function called main, which takes an object with the event parameters. You can do your computation, and then you're going to return an object, which is the result of the API request, and it's kind of serialized back out to the platform. So you can see it's really, really lightweight, nice way to be able to enable your microservices for the kind of OpenWhisk platform. You just have to add a particular function, and then you're kind of ready to go. So once you've finished your code, right, you finish your microservice code, you've got your service platform account, you've added the interface, and then you push the code into the platform. The platform creates what's called an action. And an action is the name we use in OpenWhisk for serverless functions. I think of them as like sleeping microservices waiting to be woken up whenever API requests come in. So let's have a look at doing that now. Let me take some development code from my laptop and push it up into the platform and kind of show you it working on demand. Now, because this is a conference, obviously the Wi-Fi doesn't work. However, I've presented at conferences before, and I kind of expect this. So unfortunately, I'm not going to do the live demo. I'm going to show you the video of me doing the live demo, which I recorded about an hour ago in my hotel room, because I thought this might happen. And you'll just have to trust me that it all kind of works. So let me open this video that I recorded and press play. And kind of talk over what's going to happen. This is easier because then I don't have to remember. OK, that's better. Right, now you can see. So I said that OpenWhisk is open source, right? So you could just go to github.com. You can download the whole platform. You can run it locally in a VM if you want to play around with it in development. You can actually deploy it yourself to any infrastructure provider. But I think for most people, the easiest way to get started is just to go and sign up for an account with IBM's cloud. And we offer you a service called IBM Cloud Functions, which is just a hosted version of OpenWhisk. So it's the same open source platform, just kind of hosted for you in the public cloud. And you get a very generous free tier to get started. So you just kind of go up and have a play around. So once you've signed up for an account, whoever your OpenWhisk provider is, the next thing you need to do is you need to get your code from your laptop and push it up into the serverless platform. And so the way all serverless platforms do this is there's a little command line utility that you can install locally that you then use to push your microservices up into the platform, to invoke them on demand, and to get the results of your computation. And OpenWhisk is no different. There is a little command line, little binary you install into your path on Linux or Windows or Mac. Then you set up your authentication. So obviously you need to put your username and password in for the account. And then you're kind of ready to go. So let me kind of do this now and show you a kind of hello world. I think it was the hello world example of creating our first serverless function. So because I use OpenWhisk every day, I have the command line utility installed and all configured and set up. And when I'm typing the command WSK, this is just kind of talking to the remote cloud platform in the public cloud. So what I want to do is just run you through a very, very simple hello world example with some sample JavaScript. So I have a sample function here called hello world. And you'll see it's just a tiny, it's like 3 or 4 lines of JavaScript that we're going to use as our first serverless function to just demonstrate how it works. So you can see in this file, there's a function called main, which is the interface that OpenWhisk expects. So whenever an API request comes in, it's going to evaluate our code and call this function with the parameters. It's going to get an object in, which has the event parameters. And then it's just going to return me an object. It's going to return me a greeting string saying, hello, James, hello, Sally, with the results of my computation. So not very intelligent, but actually we're just trying to demonstrate the kind of workflow. So to do this, using the command line, I can type whisk action create. You give your serverless function a name. You give it the path to the source code. It's going to deploy that to the public cloud. Then you can type whisk action list to show that it's been kind of instantiated correctly. So you can see that I have a serverless function called hello, my workspace, and it's using the Node.js runtime, which is kind of expected. And now I can just invoke it on demand using the command line to check it works. So I can say whisk action invoke. I give it the name of the serverless function, hello, and then it's just going to create my Node.js environment in milliseconds, inject my code, evaluate it, and then give me the results back, which you can see there. So that's the result of my Node.js code being executed somewhere in the cloud. And you can see I can call it again. I can call it 1,000 times in parallel, and it's just going to work. I don't need to think about scaling and resource planning and servers. I can just execute it on demand. And you can see I can pass in parameters for the user to show you that it kind of really works in the command line. So that's the kind of development workflow you go through with serverless functions, where you code them locally and then you push them up using the command line. But that's a very, very simple example, right? It's not a very useful microservice. So what I would like to do is to show you something that's maybe a little bit more realistic. Now imagine you work for a retailer who wants to, during the checkout process, integrate Bitcoin into their application. And Bitcoin as a currency fluctuates quite a lot. It changes kind of day to day or even hour to hour at the moment. So you don't want to hard code those prices in your kind of application database, the product database. You want to, during the checkout process, have an API that will convert from euros or dollars into Bitcoin during checkout. So I actually have a serverless function that I wrote to be able to do this that I want to deploy to OpenWhisk and show you how it kind of gets working, which is hopefully a little bit more of a kind of realistic example. So I'll wait for when I was doing the demo for myself to catch up. Okay, so I have this Bitcoin folder, and I have this file called conversion.js. And in it is just a bit of JavaScript which implements our Bitcoin conversion API, right? You can see it has a function called main, which takes, it's going to call by the platform. It has parameters, where it's going to look for an amount and a currency. So this is, 1,000 euros, $10,000 that we want to convert into Bitcoin. And what it's then going to do is going to go and talk to an external JSON API published by CoinDesk, who is a Bitcoin wallet, which gives you the real-time spot financial market prices for Bitcoin. Use an async HTTP request to go and retrieve the current Bitcoin prices, do a little bit of math to convert it into from Bitcoin, euros into Bitcoin, and then kind of show you how that works. So if I want to deploy this to OpenWhisk, we just do the same thing. We say whisk action create. I give it a name. Let's call it Bitcoin. I give it the path to the JavaScript file. I'm going to click OK. And now I can try it out. I can try out my serverless function to do Bitcoin conversion. I can say whisk action invoke Bitcoin, give it 2 parameters, an amount. So let's try, what did I do? I did 10,000 and a currency. I think I did euros. And it's going to go and invoke my function, which calls the JSON API, which does the math, and eventually gives me back the result of my computation. So there we go, right? There's a serialized JSON response from doing my Bitcoin API. And I can try it with different currencies or different amounts, and it's just going to work, right? No having to worry about it. So really, really quickly, right, I've got some microservices code, some API code for my laptop, pushed it up to the public cloud, and now I can kind of execute it on demand. So, okay. So once you've got your serverless functions running on the platform, right, how can you integrate those into your application? How can you call them programmatically to be able to talk to your microservices from the front end? Well, with OpenWhisk, there's a couple of different ways you can do this. The first is using what we call the platform API. So the OpenWhisk platform has a very well documented, with a Swagger doc and really good documentation, API for doing everything with the platform, from creating serverless functions to invoking them on demand. All you have to do is send a HTTP request request from your mobile app or your front-end app to the platform, and it will kind of invoke your serverless functions on demand and give you the results of your computation. And actually, rather than you having to manually construct the HTTP headers to be able to talk to the platform, there is actually client libraries for JavaScript and Swift and Python to make it much, much easier to do, which is a really nice way for using any of those languages. Now, if you're talking to the platform APIs, you have to use your developer credentials to authenticate the request, and it kind of gives you full access to the platform. But with serverless functions and with microservices in general, often we want to build public APIs or public endpoints that you can talk to without having to use any credentials at all. You know, if you want to expose them in client-side JavaScript, you can't include your developer credentials in there. So OpenWhisk actually has two different ways that you can turn serverless functions into public APIs without requiring any credentials to be able to talk to them. And the first is using something that we call a web action. So when you create your action on the command line, there's a flag, --web, that you can set to true, which will then basically, the platform will generate you a random URL that you can then call with a HTTP request from the command line from your application to be able to execute it without requiring any authentication. And this is a really, really nice way. If you just need a very, very quick way to talk to your serverless function to handle a webhook or a Slack bot, something that's just very small and kind of immediate, it's a really, really nice way to expose them through the platform, but using a kind of unauthenticated URL endpoint. So with web actions, you can talk to it through the platform API, through a random URL that gets generated, but the difference is you don't need to use your developer credentials. Now, if you're building bigger, more enterprise APIs, at this point, you're probably thinking, well, what about API routing, right? But depending on the operation and the path of the HTTP request, I want to call different serverless functions. What about rate limiting? I don't want people to call my function too much and cost me too much money. What about authentication in terms of the developer or the user having OAuth to provide their credentials so I can talk to backend services? Well, if you're using web actions to implement your APIs and you want to add those features, you have to do it all manually in the code. And that's not a very scalable way if you're building very high traffic APIs or lots of API endpoints to have to re-implement those features every time. So what most people do in this scenario, and this is the strategy for building kind of enterprise APIs as serverless platforms, is they involve what they call an API gateway. So API gateways are third-party cloud services that all big cloud providers have. So IBM's got one, Amazon's got one, Google and Microsoft have them as well. And what those API gateway services like to do is create public endpoints, public APIs, that then will call your private APIs in the background. And with OpenWhisk, you can have an API gateway calling the platform API. And the nice thing about API gateways is they handle all of those things we just talked about. So things like rate limiting and routing and authentication, the API gateway can take care of automatically, and you don't have to handle that in your code anymore. And it's a really, really nice way with serverless functions to build enterprise APIs using an API gateway to take care of all of that kind of harder stuff, and you can just focus on your business logic. So let's kind of take the Bitcoin serverless function we created and actually expose it as a public API that anyone could call. By first exposing it as a web action, show you how that works, and then actually using the API gateway. Yeah, okay, so let me open QuickTime and play the video. Cool, okay, so let's expose the Bitcoin function to begin with as a web action. So again, you can just do this through the command line. So you just say whisk action update, because it already exists in the system, you don't say create. I say Bitcoin is the name of the function, then I set the flag to true, --web. And once that's been updated, you can then retrieve details about the function. And if you use the --URL flag, it's going to give you the URL for the web action. So now I can just call this from the command line with my little utility for making HTTP requests. And without any authentication, I can invoke my serverless function. So I'm going to say HTTP get the URL. I'm going to say I want JSON back. And then I need to pass parameters for the amount and the currency. So you just use query parameters in the URL, and it kind of translates that and calls your function with those. So now I'm calling my serverless function via a kind of random URL on the platform, and hopefully it should give me back the same JSON. So it's the same result from calling my function through the command line, but now I've got a kind of a web action that I could use for a webhook or a chatbot or something like that without really having to do too much or set anything else up. Now, imagine my Bitcoin function gets really popular as an API, and so I want to think about authentication or rate limiting or any of those kind of things, and I want to be able to add on API gateway integration. Now, OpenWhisk comes with an API gateway integration kind of built in, which is really, really nice that you can use. And you can just use the command line to control it. You can say whisk API delete, whisk API create. But I think it's more intuitive to you if I show you how to do this through the web management console in IBM's cloud. I think it just makes a bit more sense. You'll probably see when I create an API why I've done it this way. So if I go back to Chrome now, and I go to this is just the web management console for IBM Cloud Functions, which is OpenWhisk. You can see I've got this little tab, this little panel called APIs, and I can say, OK, create me a new OpenWhisk API, and now you can fill out all the details. I can give my API a name, we'll call it Bitcoin. I can give it a path, we'll say API, and you can see now I can set up routing. I can say when this path is called, call this function, and when this path is called, call this function. I'm going to call the action Bitcoin, which is the one I created. I'm going to give you back some JSON. And now you can see you can actually turn on all those features. You can turn on authentication or rate limiting or OAuth or cause support, and you don't have to worry about that in the code yourself, which is really, really nice. So if I click save, what it's going to give me is a unique URL, again, on the API Gateway platform, not on the OpenWhisk platform, that I can talk to, again, using HTTP requests, but it's going to be completely separate from the OpenWhisk platform. So if I copy the URL and go back to my command line, I can just test out it works. So I can say HTTP GET, I can give it the URL, and I say it's API Bitcoin, and I give the parameters again, amount and currency, and hopefully it should just work. This time I'm trying 50,000 euros and see how much Bitcoin that was about an hour ago. So, OK, it's worth about 14 Bitcoins. And you can see now this URL that I've got is completely separate from the OpenWhisk platform. It's an API Connect.IBM Cloud. And I can use the API Gateway to add all those enterprise features without me having to think about it. And this is the pattern in serverless development. If you're going to build APIs, generally people tend to use API gateways to take care of a lot of those features, and you don't have to worry about it. OK. Cool. So in the scenarios and the use cases that we've just been talking about, it's been very much about building an API that you're going to call programmatically. Right? I'm going to call this from my code. I'm going to block waiting for the result. And I'm going to use the result of the computation. But the other big use case they talk about for serverless cloud platforms is building what they call event-driven applications or event-driven architectures, where your serverless functions can be automatically invoked whenever some external event occurs, be that a message being pushed on a queue, a database being updated by a new file in an object store, and the platform should automatically invoke your function to process that request without you having to do anything. And all serverless platforms generally support connecting your functions to external event sources, and OpenWhisk is no different. So in OpenWhisk, you can create what we call triggers that listen to these external event sources. So you can create triggers that will listen to message queues and databases and object stores and all this kind of stuff on webhooks. So whenever, for example, with a message queue, whenever there's a message pushed onto the queue, the platform will automatically fire the trigger within the system with the message details for you to be able to process. And the way you create triggers is, again, just using the command line. So you say whisk trigger create. You give it the name of the trigger to identify it. And then there's a flag, --feed, where you can give the parameters of what the event source is and how to be able to connect to it. Now, all serverless platforms support slightly different event sources, and these are the ones that OpenWhisk supports at the moment. So it has the ability to listen and create triggers which listen to Apache Kafka. Apache Kafka is a very popular open source kind of distributed message queue. So that means that you can have your serverless functions listening to messages from Apache Kafka. CouchDB as well. CouchDB is another very popular open source NoSQL database. So whenever the database changes, triggers can be automatically fired. There's one for RSS feeds, for mobile device events, for GitHub notifications. And another popular event source in serverless world is some kind of alarm or scheduler, so that you can have your triggers fire every 5 minutes, every hour, every Tuesday at 3 o'clock to be able to kick off background processing automatically without you having to kind of manage that state. And in OpenWhisk, when you've created a trigger that's listening to one of your external event sources, you can then enable rules within the platform that say, whenever the trigger is created, I want you to fire off my action, my serverless function. And you can have multiple functions all listening to the same event source. And when those actions, when those rules are created, it binds your trigger to your action. So whenever the trigger fires, your serverless function is fired automatically by the platform. And again, to create rules, to bind your actions and triggers together, you just say whisk rule create, you give it a name of the rule to identify it, and then you just give it the name of the trigger and the action, the serverless function that you want to connect together. And once that's created and enabled, anytime your event fires, your message gets pushed onto a queue, your database gets updated, your action is going to be called with the parameters of that event to process requests. And this is how you can start to build up kind of event-driven applications using serverless platforms. So hopefully over the past sort of 20, 30 minutes, I've managed to sort of talk to you why I'm personally so passionate about service cloud platforms and why I think they're a huge advantage over traditional ways of kind of building and deploying microservices to the cloud. And maybe you agree with me, right? Maybe you think that service cloud platforms are the future and you're ready to go back to your office on Monday and start setting fire to all your servers and be finished with looking after the infrastructure forever. But before I do that, right, before I kind of, you start burning all your servers, it's only fair of me to talk to you about some of the challenges of using service cloud platforms today, because it's still a very new and emerging technology space. Service cloud platforms have only been around for around 3 years. There's no standardization between any of the vendors, and there's definitely some challenges to using them. So I want to talk about some of these you might run into and give you some potential solutions as well. So the first big challenge that people run into with serverless cloud platforms is around the compute limits. So serverless cloud platforms are very opinionated about the kinds of applications they expect to run. It's not, you can't just lift and shift any traditional application and port it over to serverless cloud. It's about modern cloud-native microservices designed to run in public cloud infrastructure. And one of the ways that the platforms enforce this architectural style on you is by limiting access to some of your computational resources for when your code is running. So for example, these are some of the limits that OpenWhisk gives you. And two of the big ones that people run into on service platforms. The first is around timeouts. So when your function is running to process a request, it has a maximum of 5 minutes to finish processing. If it doesn't finish, it just gets killed off. Right? And so if you have a bit of your application that is very, takes an hour to compute some fantastic algorithm, right? It's not going to be suitable for running on service cloud platforms. And that is a hard limit. You can't go past it. And it's the same on pretty much all providers today. They've all settled on around 5 minutes. Because service cloud platforms are for quick request response event processing. It's not for super high performance computing. The second limit people run into, I think, as well, is around the use of memory. So you get charged for the milliseconds that your function's running, but also the amount of memory it allocates, and you can change the maximum amount of memory it's allowed to allocate to constrain costs, but then obviously improve performance as well. And what you'll kind of find is that you can allocate memory in the order of like 0.5 gigabyte or 1 gigabyte or 2 gigabytes as a kind of maximum. But what you can't do is allocate like 1 terabyte of RAM during your service function being executed. So if you need 1 terabyte of RAM to do your calculation for some crazy algorithm you've got, at the moment service cloud platforms aren't kind of appropriate for that workload. But my advice to you around limits is, get to know the limits of the platform and kind of embrace it and build your application to architecture to suit these limits, because really they're there to help you build microservices designed to run in the public cloud. Okay, second challenge to be aware of is around monitoring, debugging, and testing, right? All those things you do to keep your application healthy when it's running and also healthy before it even gets to the cloud. Now, monitoring and debugging are particularly challenging with service applications because a lot of the techniques and the strategies we have for monitoring and debugging rely on having physical access to the environment, right? You have to SSH into the machine, look at the logs, you have to grep system calls, you have to run top and work out what's going on with your bad process or attach a debugger. And you can't do any of those things because you have no access to the physical environment, right? So what are we going to do? Well, you still get access to serverless cloud platforms to standard out and standard error, right? Logs are still available from your application through the platform API. So you need to make sure that your microservices have really, really good logs, that you can change the level of the logs using an environment variable or something to be able to get production traces out if things start to go wrong in production. Because a lot of the more advanced tools that we use for debugging, for monitoring and debugging, don't work in serverless platforms. And it's one of the big challenges today with kind of production serverless apps is the monitoring and debugging part of it. Testing is also kind of interesting story. Unit testing, I think, is really, really easy for serverless apps because you're building very defined, identifiable serverless functions that you can use test harness to pretend they're being called on the platform and just use unit testing to check they work. But what's quite challenging, I think, is system testing, because how can you simulate someone else's infrastructure? You're running on someone else's infrastructure, you're using loads of cloud services, you've got dozens of functions all calling each other in parallel. It's kind of difficult to get a realistic system test environment locally when you're kind of doing development. OpenWhisk, I think, helps with this a little bit because it's open source. So it means you can actually run the full platform in a VM locally, and that's what a lot of people do to get a more realistic system test environment. But it's not perfect, and again, this is one of the challenges, I think, of serverless development, is how you do realistic system testing. Okay, final challenge that I think people run into quite a lot is around the kind of increasing complexity. So if you're used to doing development where you have a physical server and a database and all your code's on the server, the idea of decomposing your application into a dozen independent serverless functions that use loads of cloud services and all talk to each other concurrently probably strikes you as just a huge increase in complexity. And we know one of the downsides of microservices is this increased organizational complexity in terms of build and deployment and rollout and management. And serverless functions has that in spades, really. So what can you do to manage some of this? Well, my advice is to definitely check out some of the frameworks that exist today for doing serverless development. Whatever your language and whoever your provider, there's some really good serverless frameworks that have been out for a couple of years now that can help to manage, especially the build, packaging, and deployment of your applications, rolling back if things go wrong, rolling out new versions concurrently. My favorite and the most popular out there today is called the Serverless Framework. It's open source, it's very, very popular. It supports all of the big four serverless providers, so you get a bit of an abstraction there, which is quite nice. And it completely reduces the barrier to getting started with serverless development by hiding a lot of the packaging and deployment, which can be a little bit complicated for kind of bigger apps. So definitely go and check some of those out. So I said at the start of this talk that servers kill your productivity. And maybe, hopefully, now you agree with me, right? All of that time spent managing VMs and orchestrating containers and thinking about Linux versions and middleware and all that kind of stuff is actually time that you're not spending on building your product, on listening to users, on fixing bugs, on shipping new versions. And I think as developers, it could often feel like you're held hostage by your infrastructure, right? I want to spend time writing code, and I spend increasing amounts logged into some remote Linux environment trying to debug my kernel panic. So I want to kind of encourage everyone here today, if you're building modern kind of cloud-native microservices in the public cloud, think about embracing the serverless revolution, right? Burn your servers, deprovision your virtual machines, delete those containers, be free of the tyranny of looking after infrastructure forever. But more importantly, right, upgrade your productivity. Stop spending your time managing kind of VMs in the cloud and get back to kind of writing code. So thank you very much for listening. If you want any of the resources from this talk, take a photo of this slide because there's a bit.ly link at the top that will get you to a GitHub repo with all the codes and instructions about how to get started, and you can kind of follow along at home. If you want some more help with OpenWhisk, there's a Slack group, and I've actually created a Slack channel in the Pixels Camp Slack called Serverless, so if you want to talk to me afterwards or get some help with your project, I actually think Serverless is a great platform to use for your hackathon because it's free and it's really easy to get started. You don't need to manage anything, you just write your code and throw it up. So I'd encourage you to do that and come and talk to me in there. Obviously Stack Overflow, that's where we ask questions. And then after the conference, if you need help in the future with any serverless stuff or OpenWhisk, just tweet me, I'm at Thomas J, and I can come and kind of help you out. So thank you very much. I think I'm bang on time. Have we got any questions? I think we've got about 10 minutes. Don't all rush at once.
Hi. Are there any best practices in terms of reducing code when you duplicate code because you only have a function, right? If you have some module that are filled with utilities for your app, you have to keep replicating that code in each serverless function?
So one of the things you can do in terms of, so sharing code is something people are like, okay, when I have one function, fine, and when I've got 20, how does that work? So that's something that the frameworks take care of often quite a lot for you. They manage the whole packaging and sharing of code between functions, and they take care of that. So that's what the frameworks help with a lot. With some serverless providers, you can actually upload a zip file with all your code into an object store, and then you can just create your serverless functions by saying, there's the code for all of the serverless functions, but I want you to call this particular one for this endpoint. So yeah, there's a couple of things you can do, and that's something that frameworks help a lot with, is the bundling and the packaging and the sharing. So yeah, you don't have to replicate all of, if you have a utility, it's very easy to share between your functions. You don't have to completely kind of have copy and paste code everywhere. So yeah. Anyone else? Don't be scared. Okay, there's one to your left.
Hello.
Hey.
How do you go about testing code locally and building stuff without having to constantly push things to, in this case, Whisk?
Yeah. So there's a couple of different ways people do this. What most people do is they keep the core business logic abstracted away from the interface to talk to the platform, and then they have just really, really good unit tests for testing the core business logic. The challenge, as I said, is when you want to do kind of system or integration testing, with service development, you often use lots of other cloud services. You kind of outsource as much as possible. So it's kind of difficult sometimes to be able to replicate that in kind of locally. There's a couple of different things people do. With OpenWhisk, you can run the whole platform just in a VM locally, the whole platform locally, and people will often use that, so they'll be deploying to that just locally, and then once it's done, then they'll push to their CI, and the CI will update the production version. There's some simulators people have written for different platforms. So I know for Amazon's cloud, they have like a simulator, which kind of it's just like a fake runtime that you run locally and push your code to. And there is one for OpenWhisk as well. It's a bit more challenging. But most people, if you're using OpenWhisk, what everyone seems to do is they just run the full platform, a test VM locally with the whole thing in. They'll develop against that. They unit test a lot, then they'll system test locally, and then they'll just push to production. Another thing you can do is, obviously, because the compute is free, and not free, it's extremely cheap, and you can create kind of limitless resources, you can kind of just push up to another workspace, and test it there, because it's not like you're sharing a server or you're going to break the production server. You can just push up to you have a concept of like workspaces. You can push up to like a development workspace and just kind of test that out there. So yeah, the way I do it personally is I just unit test really heavily locally, and then I just push to deployment when I'm kind of ready. Because unit testing is, the nice thing about the testing is that you have very defined entry points into your code. You know what you're going to call this function, and all you have to pass in is an object, and you're going to get an object back. Super, easy. Not a lot of state, and your functions have to be stateless. So that's nice. It encourages it, but it is more of a challenge. And the same with debugging. When things go wrong, it can be quite challenging, right? I think these are all problems that the platforms are focusing on this year. So this year has been a real focus on tooling and vendor and developer experience, and they're really heavily focused. So I think they're all fixable problems, and in a year or two, it'll have all been fixed. But they're some of the things to think about.
Thank you. Looking forward to that.
Cool.
So, if you have a private API that is only used for our company internally, should we still use an API gateway to manage all this complexity of identity, authorization, and so on?
Yeah. That's a good question. I guess the answer is it depends. I think if you are happy, if you just want to be able to call a microservice, one of the serverless functions from your code, and you're not worried about it being publicly accessible at all, most people just use the private API with your credentials, as long as you have a secure way to store your credentials in your app, right? If you don't have to worry about security, that's fine. And the client libraries for Python and JavaScript make it so easy. You don't have to worry about the HTTP request. You just install the client library and use it and say, call this function, and you get back the results. So no, if you're just developing some services internally, just call it through the platform API. Don't worry about the API gateway. It's more for either public APIs for like a public web app, or if your product is an API, that you sell other people, then you want to add that. But no, for most stuff I do, I'll just call the platform API using a client library, because that's fine. I don't have to worry about my developer credentials and that kind of stuff. Let's see. Okay, anyone else? Got 5 minutes. Okay, maybe not. So if you have any questions, you can come and talk to me afterwards. I'll be around all conference. And yeah, if you want help getting started, I'm happy to just sit down and go over it with you. Or you need help with your hackathon, just come and find me in the Slack afterwards. And we can, if the Wi-Fi is working, hopefully, then we can just kind of have a chat. So thank you very much.